In this video, we are going to determine the work underneath a force versus displacement curve. Let's say you were pushing a table to the right with a force of 6 newtons and you kept pushing it for a distance of 8 meters. And we wanted to know how much work was done. Well, this is a simple problem because all you would have to do is plug it into the work formula. But let's say we want to plot this on a force versus displacement graph as shown right here. And you can see that we push this table with a constant force of 6 newtons for a displacement of 8 meters to the right. Now remember, work is equal to Fd cosine theta. And for this case, we do not have to worry about our angle because we are only considering the force vector that's being acted in the same direction as our displacement. In other words, since the force vector, which is you pushing the table, is pointing in the same direction as a displacement vector, the angle between the force vector and the displacement vector is going to be 0. So the work is going to equal Fd cosine of 0. And we know that cosine of 0 is 1. So our work formula is going to equal Fd. But remember, you can only write it like this to solve forces that are pointed in the same direction as the displacement. So now let's plug in what we know into this formula. So work is going to equal the magnitude of the force, which is 6 newtons, times the displacement, which is positive 8 meters, and this will give us a total of positive 48 joules. And you may notice that's the same thing as the area underneath this rectangle. The force of 6 newtons is the height of this rectangle, and the displacement of 8 meters is the width of this rectangle. So if we just multiply the width times the height, we will get that the area of this rectangle is equal to the work done for this problem. Now you may be wondering, what's the point of plotting this when you can just plug it into the formula? Well, this problem was not too bad because the force was constant. But when you have problems where the force is changing, then you will not know what force value to plug in to the formula. So knowing that the work is the area underneath the curve is a very useful technique. So now let's look at a problem where the force is varying. In this problem, we're given a force versus displacement curve. And we want to know how much work has been done from 0 meters to 10 meters. And we're going to assume that the force and displacement vectors are in the same direction so that our angle is 0. So the way to solve this problem is to break up our curve into basic geometric shapes. There are many ways we can break up our curve, but I'm going to break it up in the way I think is easiest. So we're going to have a triangle. Let me move this over here. We're going to have a trapezoid, and we're going to have a square. Now using our geometry skills, we can find the area of each of these shapes and add them together to find the total work from 0 to 10 meters. Let's solve for the area of the square first. So the area of the square is width times height. And we know that our width is 8 meters. And we know that our height is 8 newtons. So we'll have 8 newtons times 8 meters. And this will give us positive 64 joules. Now let's solve for the area of the trapezoid. The formula to solve for the area of the trapezoid is 1/2 times the height times base 1 plus base 2. And we know that the height is 10 newtons minus 8 newtons, so that's 2 newtons. So we have 1/2 times 2 newtons times the length of base 1, which is 8 minus 4 meters, so this is 4 meters, and the second base is 8 minus 6 meters, so that's 2 meters. So we'll have 4 meters plus 2 meters. And this will give us positive 6 joules. Now let's solve for the area of the triangle. So the area of the triangle is equal to 1/2 times the base times the height. So the base of the triangle is 2 meters. So 1/2 times the base, which is 2 meters. And the height of the triangle is 10 newtons. So we'll have 10 newtons. And this equals 10 joules. Now that we found each of these areas, we can add them all together to find our total work. So our net work is going to equal positive 64 joules plus positive 6 joules plus 10 joules. And this will give us a total of 80 joules. So in recap, if the force and displacement vectors are in the same direction, then the area underneath the curve is equal to the work done. And if you have a constant force, then you can use this formula, W equals FD, instead. Thank you for watching this video, and hope to see you next time.